In this lecture, we discuss a powerful advanced feature of HDF5 that allows you to compress HDF5 datasets to save space on disk. HDF5 compression is also a special case of a more general feature in HDF5 called the filters. Filters provide many flexible options for you to control how your data is stored on disk. One general advantage of HDF5 over text formats like CSV is that it's a binary format. In other words, data that had to be stored before in ASCII can now be stored using only 2 or 3 or 4 bytes per number, saving a large amount of disk space. It's also very common in the real world to have data files which are very redundant. In other words, they have lots of repeated data. With ASCII-based text files, a common solution is to simply put the files into a zip file to compress them. We could use this strategy for HDF5, but we don't want to compress and decompress the entire HDF5 file every time we interact with it. And if our HDF5 file contains multiple datasets, it's very wasteful to compress and decompress other parts of the file. So the challenge is, how can we avoid compressing or decompressing our entire HDF5 file, and keeping in mind that datasets may be gigabytes or larger in size, to avoid compressing or decompressing even an entire dataset? A solution that comes to mind is to divide the dataset into pieces, and then compress and decompress each one individually. That way, we only need to do compression or decompression on a piece of the dataset we're accessing. Of course, HDF5 already has a built-in mechanism for this, in the form of chunks. In HDF5, compression is implemented as something called a filter. For HDF5 datasets that are composed of chunks, those chunks can have transforms applied to them on their way to and from the disk. In the case of compression, a chunk that's in memory will be compressed before it is stored on disk, and then, if later retrieved, that chunk will be decompressed and returned to memory. The operations you can perform on a chunk are not limited to compression. For example, if we wanted not only to compress our dataset, but also verify its contents, we might have another filter that adds a checksum. That way, if data on disk is corrupted at any point, the checksum filter will warn us. We can arrange the compression filter and the checksum filter together into what's called an HDF5 filter pipeline. In other words, data flows from the disk through each filter in the pipeline and then into memory, and then when data is saved to disk, it flows through the pipeline in reverse order. Here are some things to keep in mind when using HDF5 filters. First, filters apply on a per dataset basis. In other words, you can mix compressed and uncompressed datasets in the same HDF5 file. Second, because filters apply to fixed blocks of data, your dataset must use chunked storage. And once your dataset is created, the list of filters is fixed and can't change. Importantly, if you have a dataset with filters, for example compression, you can perform all reads and writes normally. HDF5 performs all filter operations in the background and is completely transparent to the user. HDF5 supports a wide variety of filters. It's important to remember that certain filters are provided by the HDF group along with HDF5. These filters are available anywhere HDF5 is available. Therefore, they are by far the best for sharing data. Some filters from the HDF group include the checksum filter and many compression filters that are appropriate for different use cases and data. There's also a wide variety of filters provided by the HDF5 community. These are compatible with HDF5, but must be downloaded and installed separately. The HDF group maintains a full list of all filters in common use at hdfgroup.org, including links to the filter authors and where you can download them. Let's see an example of how to use filters from H5Py. In this example, we're going to create a compressed dataset using the gzip compression method supplied by the HDF group. Recall that filters are set when a dataset is created, so we're going to use keyword options to the method createDataset. The compression method is specified by the keyword option compression, and parameters, for example, the gzip compression level, is set by the keyword option compression ops. Here, we're making a new dataset that has shape 100,000. We're specifying the gzip method, and setting the compression level to 9. Once we've created the dataset, we can check the compression property and the compression ops property to see the strategy and the level in use. The create dataset method also includes other keyword arguments, for example, shuffle and Fletcher32, that correspond to other HDF5 filters. If you turn these on, H5Py will add these filters to the filter pipeline. Let's take a look at how you can use the HDF5 compression filters to reduce the amount of space on disk required for a dataset. First, we'll use the NumPy package to generate some data to store. We'll create a new array with the first 1 million integers. Next, we'll create an HDF5 file that contains one dataset, uncompressed, with this information. First, we import H5Py, then create a file Next, we'll make a new dataset and make the size 1 million elements with the type of 32-bit integer. We'll use NumPy slicing to fill our dataset with data. And we can check to make sure the data has been written. Now, let's close the file and examine the file size. As we expect, it's about 4 megabytes. 1 million elements, 4 bytes per element. Now, let's create another file, but this time using a compressed dataset. We use create dataset as before, of the same shape, but this time, while the type is the same, we specify a compression of gzip. In other words, using the HDF5 gzip filter. Now, we can store our 1 million element array in this dataset. We can close the file and examine the file size. So, by adding a single keyword argument, we were able to reduce the file size by almost a factor of 3. Keep in mind, the trade-off here is that it takes some extra time to perform compression and decompression. So make sure you do testing for your use case. To summarize, filters can be used, among other options, to compress data stored in HDF5, and they apply on a per dataset basis. You can apply more than one filter to an HDF5 dataset. In H5Py, filters are specified using keyword arguments to create dataset, and the pipeline is built for you. Importantly, the entire process is transparent for reading and writing data. We can use our usual methods of NumPy slicing and indexing, and HDF5 will handle all compression and decompression for us in the background.